Hello everyone, welcome to the next lecture. In this lecture we are going to solve an important problem like this. So the problem is the charge flowing in a circuit element is plotted in the figure. The plot for the current will be I of t will be equal to, so this is I of t here, and it is drawn between, so the axis represents the time, okay, time in seconds, okay, here also, okay. So we need to find the waveform, like we need to plot the current waveform I of t with respect to the variation in your charge, okay. So we know that I of t is equal to d by dt of q, okay. So as you can see, from 0 to 1, the charge is q, the value of q is 0. It means that the value of the current will also be equal to 0, okay. So from the interval from 1 to 3, okay, the waveform of the charge with respect to time is a straight line, okay. So the equation of straight line will be equal to, so it will be equal to your q minus 3, okay, is equal to the slope of this particular line. It is 3 minus 3 minus 0 upon 3 minus 1 and t minus 3, okay. So the equation of this particular line will be equal to your q minus 3, so 3 by 2 t minus 3, okay. So it will be equal to your q is, so this equation will become q is equal to 3 by 2 t minus 1, okay. So this is the equation of charge between the interval 1 to 3. So the value of the current I of t will be equal to differential of this, okay. So d by dt of your 3 by 2 t minus 1, okay. So that comes out to be 3 by 2, which is your 1.5, okay. So between the interval 1 to 3 we are getting the waveform whose magnitude, we are getting a straight line with a magnitude of 1.5, okay, amperes, okay. So the value of the current between the interval 1 to 3 will be equal to 1.5 amperes, okay. So between the interval 3 to 5, okay, we are getting a straight line. The equation of the charge will be a straight line with a negative slope. So the value of the current will be equal to, so it is minus 1, okay, minus 1 coulombs, and so it will be equal to, q will be equal to, the equation of the charge will be q minus 1, which is into minus 1 minus 3 upon 5 minus 3 t minus 5, okay, is equal to minus 2 t plus 11, okay. So this is the equation that we are getting, okay. So current will be equal to differential of this, okay, so that will be equal to d by dt of your minus 2t plus 11, and that is coming out to be your minus 2 amperes, okay. So between the interval 3 to 5, we're getting the value of the current to be minus 2, so it will be minus 2 amperes, okay. So, okay, between the interval 5 to 6, okay, so between the interval we can see that q, the charge, is basically a straight line, okay, with a zero slope. So it means that the equation of the q will be equal to, so it will be equal to, q is equal to minus 1 coulombs between the interval 5 to 6 seconds, okay. So the value of the current will be equal to d by dt of your minus 1, and we are getting the value of current to be 0. So it means that the value of the current between the interval 5 to 6 will be equal to your 0 amperes, okay. So between the interval 6 to 7, your 6 to 7, in the same way the equation of the line, so equation of the charge, okay, will be equal to q of t is equal to, So q of t is equal to t minus 7. Okay, so the value of the current will be equal to I of t between the interval 6 to 7. It will be equal to d by dt of your charge. Okay, with t by t minus 7. Okay, so you're getting a value to be equal to 1 amperes. Okay, so the value of the current in this interval will be equal to your, it will be equal to your 1 amperes. Okay, so that's all for today, guys. I will see you in the next lecture. Thank you.